Hello everyone. Today we're going to start a new chapter, and the name of the chapter is Triangles and its Properties. So in this chapter we are going to deal with triangles and the different kinds of properties that a triangle has. So first of all, let us discuss what is actually a triangle. So first of all, we will be discussing what is a triangle. So let us go back to the definition of a triangle. A triangle is a closed figure bounded by three line segments. So as you can see in the figure, here there are three line segments AB, BC and CA. So when they are joined together to form a closed figure, then it is called a triangle. So here ABC is a triangle. Also, a triangle has three vertices, three sides and three angles. So we will come to that. Now as you can see here, ABC is a triangle. Now in this triangle ABC, what things we have? We have sides, angles and vertices. So first of all, let us see the sides. The sides are AB, BC and CA. What about the angles? Angles are angle ABC, angle BCA and angle CAB. So these are the three angles in this triangle. What about the vertices? There are three vertices. A, B and C are the vertices of this triangle. Next, classification of triangles. So what are the different types of triangles that can be formed? So let us see that. Triangles can be classified based on their number one, sides, and number two, angles. So based on their sides and their angles, we can classify them into different types of triangles. So let us see how many types can we classify based on their sides. So based on their sides, we can classify them into three types. Number one, scalene triangle. Number two, isosceles triangle. And number three, equilateral triangle. We will discuss in details in our upcoming slide. And what about the types of triangles based on their angles? Same. There are three types of triangles based on their angles. Number one is acute angle triangle, number two is obtuse angle triangle, and number three is right angle triangle. So these are the different types of triangles that can be formed based upon their sides or angles. So let us now discuss in details. First, let us discuss about the triangles, or you can say the different types of triangles that are formed on the basis of their sides. So the first one was scalene triangle. So what is a scalene triangle? A triangle in which all the three sides are of different lengths is called a scalene triangle. So if a triangle, you can see here, EGO is a triangle. So here in this triangle, the length of the sides are different. The side EG length is 7 cm, the side GO length is 14 cm, and the side OE length is 13 cm. So in this case, where all the three sides are having different lengths of measurement, then we can say such kind of a triangle is a scalene triangle. Next one is isosceles triangle. Now a triangle in which only two sides are of equal lengths is called an isosceles triangle. So as you can see here in the triangle CAB, two sides are equal. Which two sides are equal? Side CA and side CB. They are of equal length, that is 4 cm each, whereas the third side, that is AB, is 6 cm. So in this case, where if two sides are of equal lengths, then we can say such kind of a triangle to be isosceles triangle. Next one is equilateral triangle. A triangle in which all the three sides of the triangle are of equal lengths is called an equilateral triangle. So you can see here, angle XYZ is an equilateral triangle because here all the three sides are of same length. Each of them is 3 centimeter. So we can say XYZ is an equilateral triangle. Now moving on to the classification of triangles based on their angles. So based on their angles also we have 3 different types of triangles. Number 1 is acute angle triangle. So what is an acute angle triangle? A triangle in which every angle is an acute angle is called an acute angle triangle. So we know that in a triangle there are 3 angles, and if all these 3 angles, each of them is an acute angle, then it is called an acute angle triangle. For example, here angle CAB is an acute angle triangle because all the angles, angle C is 62 degree, which is acute angle, angle A is 75 degree, which is also acute angle, angle B is 43 degree, that is also acute angle. So if all the angles are acute angle, then we can say that it is an acute angle triangle. Next, obtuse angle triangle. A triangle in which one of the angle is an obtuse angle is called an obtuse angle triangle. So as you can see here, in triangle CAB, again, one of the angle, that is angle A, is an obtuse angle, that is 110 degree, whereas the other 2 angles are not obtuse angle. Clear? So in an obtuse angle triangle, only one angle will be obtuse angle and the other 2 angles will be acute angle. So such kind of a triangle is called an obtuse angle triangle. Now next is right angle triangle. A triangle in which the measure of one of the angle is 90 degree. Just like in the obtuse angle, one angle was obtuse, and in the obtuse angle triangle, one of the angle was obtuse angle. Similarly, in right angle triangle, one of the angle will be a right angle. That means the measurement of one of the angle will be 90 degree. So let us see. So here triangle BAC is a right angle triangle. Here also you can see that only one angle, that is angle A, is 90 degree. The other 2 angles are acute angles, 60 degree and 30 degree. Clear? So this was all about the classification of triangles. Now moving on to the next topic, that is called median of a triangle. So what do you mean by median? So let us see what is a median. A median of a triangle is a line segment that joins a vertex to the midpoint of the side that is opposite to that vertex. So let me show you the figure. There is a figure, you can see. Now here AD is the median. It is nothing but it is a line segment, as you can see in the figure, and it is connecting the vertex A to the opposite side. So which is the opposite side to vertex A? BC, and is connecting to the midpoint of that opposite side. Clear? Midpoint means it is the middle point of the line segment BC. That means BD is equal to DC here. So as you can see here in the figure, AD is the median and it divides BC into 2 equal halves because D is the midpoint. So it will divide BC into 2 equal halves, that is DB equals to DC. Clear? So this was all about median. Now let us see some of the properties of a median of a triangle. Now you might be thinking, is there only one median in a triangle or there are more? The answer is yes, there are more. Every triangle has 3 medians, one from each vertex. As we know, there are 3 vertices of a triangle. Say in this example, A, B and C are the 3 vertices. So from each vertex, one median will be coming out and it will be intersecting, or you can say it will be joining that vertex to the opposite side of that vertex. Opposite side to where? It will connect that vertex to the middle point or the midpoint of the opposite side. So let me show you the figure, it will be more clear to you. So here you can see AE is a median, CD is a median, BF is a median. So all these medians are connecting the vertices A, B and C. So in the median AE, it is connecting vertex A and the midpoint E of the line segment, or you can say of the site BC. Then median CD is connecting vertex C to the midpoint, that is D of site AB. Then median BF is connecting the vertex B to the midpoint F of site AC. So these are the three medians. Clear? No matter what kind of a triangle it is, there will be always three median. Now as you can see in the figure, the three medians, they meet at one point, that is denoted by the point O. Now what is the name of the point? It has a special name, and that meeting point is called the centroid. The point where the three medians meet, it is called a centroid. Now each median, it divides the triangle into two smaller triangles. Say if you consider the first figure, the median AD, it is dividing the whole triangle into two smaller triangles. That is, the whole triangle is ABC. It is dividing into two smaller triangles, that is triangle ABD and triangle ADC. Clear? Similarly, the other two medians also will divide the triangle into two equal halves. So as a result, how many triangles it will divide? Eventually, it will divide into 6 equal triangles. So as you can see here, this area is one triangle, this is another triangle, this is another triangle, this is another triangle, this is another triangle, and this is another triangle. So altogether there are 6 triangles that will be formed by 3 medians, and all of this triangle's area will be same. Clear? So eventually the whole triangle is divided into 6 smaller triangles of equal area. Now moving on to the next topic, that is altitudes of a triangle. Now what do you mean by altitudes? Let us see. An altitude of a triangle is a line segment that starts from the vertex and meets the opposite side at right angles. Now it is similar to that of a median. The only thing is that it will form right angles. So let us see. So say for example, in this figure you can see there are 3 lines. So that means there are 3 altitudes in a triangle, just like a median. So if you consider one of the altitudes, say for example AE. So AE is connecting the vertex A to the side BC, forming an angle of 90 degree. That means it is exactly perpendicular. That line is exactly perpendicular on BC. So unlike median, the only difference is that unlike median, here it is not joining the vertex with the midpoint of that opposite side. E is not the midpoint, but it is forming a right angle. That means the altitude is always perpendicular to the opposite side, or you can say the altitude is always perpendicular on the opposite side. It is connecting the opposite side with the vertex, or you can say it is connecting the vertex to the opposite side, and it is forming an angle of 90 degree. Clear? Now in the figure you can see there are 3 altitudes, AE, BF and CD. So in every triangle there are 3 altitudes. Now let us see the properties of the altitude of a triangle. Number 1 is every triangle has 3 altitudes, one from each vertex. As I said just now, that there are 3 vertices, so there will be 3 altitudes in any triangle. No matter what kind of a triangle it is, it will have 3 altitudes. Now altitude is considered as the shortest distance from the vertex to the opposite side. Since it is a perpendicular and we know that perpendicular is the shortest distance, so that's why altitude is also the shortest distance from the vertex to its opposite side. Now there are three altitudes as you can see, and they also meet at one point, and the meeting point is called the orthocenter of the triangle. So this point O is called the orthocenter. Just like in median it was centroid, here in case of altitude it is called orthocenter. Clear? So that's all in this video for today. I hope you all have understood today's class. So next class we'll be discussing further on triangles. So till then, thank you and have a nice day.